So on my forward and reverse video, I had tried to turn on the reverse contactor, and no matter what I did, I couldn't get that reverse contactor to come in. So I'll show you a couple of things here. One troubleshooting thing that you can do is that I can jumper my common to my output, and actually I can actually fire on these outputs just by jumpering them out. So I know that this forward contactor is on my output number 2. So I'm going to go for my common, and I'm going to jumper to number 2. And you can see that it just pulled in there. Okay. I can go to number 6, and I can get a light on. I can go to 7, get the other guy on. 8, so I can clearly see that my neutrals or my returns are good. If I go to 9, I can turn on that contactor. And if I go to 10, I can turn on this guy. Okay, my PLC program is still set up for this contactor, so that's why that guy stayed on. So, but no matter what I can do, I can't get this bad boy to turn on. So I'm going to jumper from my common to 3, nothing. Common to 2 works fine. Common to 3, nothing. And they're using the same return here. I have my A2s together, and then they go through the overload below. So they're sharing a return and coming back. So the first thing I did was I checked to see whether I had actually maybe caught just the insulation of the conductor and it wasn't making contact with the copper. That wasn't the case. I checked my returns all the way back here. Clearly my return is good from here to here because this contactor is turning on. But I can't get this guy to turn on. So I've checked this wire right here. Nothing's working whatsoever. So the next thing to do is do an ohmic check on the actual windings there. So what I need to do is I need to turn off the power to my PLC. So let me just do that first. Now the reason why I turned off the power to the PLC is none of my outputs are on, but I'm just hoping that none of my outputs are on. I just want to make sure that I don't have a voltage going to my coils in any means. So I've turned off the PLC so that there's no voltage applied to the coils. Last thing you want to do, I'm taking an ohmic reading. Last thing you want to do is take an ohmic reading on something that's live. So we can see here that if I go across A1 and A2 of the coil, let me get my hands out of the way here, guys, sorry. If I go across A1 and A2 of the coil that I know is good, I can see 6.7 ohms of resistance. That's the resistance of the actual winding. If I go across all the other windings that are identical contactors, I see 6.8, and across this guy over here I see what am I seeing? 6.7. Okay, so it looks like 6.7, 6.8 is the value for the resistance, the physical resistance of that winding. If I go across this coil on my reverse, I'm getting an open. I'm getting open line or megohms of resistance. So I know that that coil is most likely smoking a pancake. So maybe somebody's put the wrong voltage to that coil. Maybe it's broken from the manufacturer. Maybe there's a contact that's not making inside the actual contactor. Regardless, it sucks because I need to take out this contactor. I need to remove it from the DIN rail. I've got to take all my conductors off, and then I've got to investigate that contactor. So you could look at it out in the field. Out in the field, I would just purchase a new forward reverse contactor, remove all the wires and put that forward reverse contactor in, and then double check later on when I had some time on the actual coil. I can see here that on the plastic it's broken on the front, so possibly that means that because there were some external contacts on the front here, so if somebody had put too high of a voltage, perhaps that had pulled in really hard and snapped that piece of plastic. So but we're gonna have to rip it apart and take a look at the coil. Okay, so I had an identical contactor that was on the side that I wasn't making use of yet. I'd like to do a video on the forward reverse starter. Alright, so I wasn't entirely clear there. I have this extra one right here that I'm not using right now. If this one's done, I'm going to take this guy, swap it out because they're the same contactor, and then I can do a video on the forward reverse contactor with an overload. And then in the meantime, I'll grab another one from the shop, or I'll fix the one that is pooched. Okay, let's keep going. So what we're going to do is we're going to take this bad boy apart. So we're going to remove all the components here. So I've got to back off these 3 terminals here. And then I'll be able to, let me just move this guy out of the way. Then I'll be able to remove the overload. So you can see that these 3 copper bus, they go into those 3 terminals there. So I can loosen those guys off and pull it out and put it to the side. Okay, then I've got these jumpers that, this is kind of cool actually, because we can go through the bits and pieces of the actual forward reverse starter. So you can see here that I've got jumpers on the bottom here. And on the bottom is where I've got T3 and T1 changing state. If we just move it up just a touch more, you can see this right here. So T3 and T1 are changing state. T2 is staying exactly the same. And then T1 and T3 are changing as well. So on either of the forward reverse, on the load side, that's where the terminals on T1 and T3 are being reversed. Okay, but let's get rid of those guys. So we're going to back off these terminals as well. And then we'll be able to pull out those jumpers there. Okay, so there's the copper jumpers that do my reversing. Okay, so we'll put that to the side. Then on the top here, let me just get this framed up properly. Okay, so you should be able to see that line 1 and line 1 tie together. Line 2 and line 2 tied together, and then line 3 and line 3 tied together. So that's where you bring your conductors into the forward contactor, and these bus bar allow that same reference to go to the line side of the contactor. Okay, so we're also going to back those terminals off and take those jumpers out. So lots of work just to get to the forward reverse, because one of the contactors was smoked. Again, there's the bus, right, that do that changing from 1 to 1, 2 to 2, and 3 to 3, or not changing but transferring from the forward to the reverse contactor. Okay, so those guys are gone. Okay, on the back there is a pin right here that needs to be removed as well. So that one there ties the 2 contactors together. So we'll take that pin out of there. Beautiful, putting everything to the side so we can grab it afterwards. And then to take these guys apart, let's see whether we can just, there we go. So we just remove them, and then the forward and the reverse can come apart now. Okay, so I want to remember which one, it's easy to remember which one is broken, because you might just be able to make out that this guy right here has this broken tab on the front. So this is my reverse starter that wasn't working. Okay, you can see here that on the forward, this is that mechanical interlock. Let's see if we can frame that up. There we go. So that little piece of metal right there, that's your forward reverse mechanical interlock. So you can see, compared to the NEMA starters, how small that little piece of metal is. That's the only thing that stops the forward and reverse from turning on at the same time. So this little piece right here, let's see if we can pull it out. That thing right there, that's your mechanical interlock between the 2 contactors. A little tiny piece of plastic with a little tiny pin there. All right, so that guy's my forward. It's most likely good. Let's take the reverse apart here. So let's see if I may need to go grab another screwdriver here. Yeah, give me 2 seconds. Let me go get a slot screwdriver to do that. Okay, so in order to get these 2 plastic pieces apart, we're just going to gently push down on this tab right here with a slot screwdriver. Then we can release them. Okay, here I'm just going to show you the voltage. Come on, Pete. The voltage rating of the coil there. So you can just make out, let me get the lighting properly, just make out that 24 volts there for the rating of the coil. Now you can replace that with the 120 volt coil as well. You just have to make sure that you have the appropriate coil for this contactor. Beautiful. So let's open this bad boy up. On the other side, there's another plastic tab which we'll press, and then we can take the top of the contactor off. So this will be removed, and we can see the inside of the contactor. Very cool. Okay, so there's our spring Okay, so that opens up our contacts. Okay, you can see the core here. Sorry, I just bumped the camera there. And you may just be able to make out the sheet steel laminations on the center here of the core. Now each of these guys are isolated, right? So same electrical steel, isolated from each other, just the same as any other electrical component that we've been looking at. They all share the same type of core there. Beautiful. Okay, so the contacts for my coil are these guys right here and right here. So when I check A1 and A2, they go to these two tabs right there, and they make contact with, what do they make contact with? These bad boys right here. So that slides into that slot right there and makes connection to the coil. So we'll just pull the coil out here. There we go. So there's the coil here. Underneath this insulation here is all the windings of the coil, and the rating again is on the front here at 24 volts. Beautiful. Okay, so there's something wrong with that coil. Let's check it out with an ohm meter now that we've gotten it away from the other components, and we'll just test across these two leads and see whether the continuity is any good. Okay, so what I'm going to do is I'm going to test out these two leads right here, between here and here, for continuity. Oh, look at that, 6.9 ohms, 7 ohms. So I thought this coil was smoking a pancake, but it looks like it's good, right? That's the exact same value that we had on the other contactors, which is a bonus. If we do the old sniff test, whoo, smells good. There's nothing that I smell that's cooked on there. Obviously, we got that 7 ohms, the exact same as we had on the other coils. There's no obvious discoloration of this bad boy whatsoever. So there must be something with the connections between these guys, and the connections that we had from the rest of the contactor. So let's take a look at that and we'll see what is going wrong, because something just not making contact somewhere in the contactor. This coil is good. Okay, so I don't know if you can make this out, but there's this little teeny tiny piece of plastic that came off here. It looks like there's a little piece, yeah, like that, right? So that piece right there looks like it is broken off on this side, right? So if we get that out of there, there's that little tiny piece of plastic there. And maybe that was what was getting in the way of it making contact there. All right, so let's get rid of that. Let's put everything slowly back together, and then we'll take an ohmic reading on A1 and A2. Okay, so that was it. These two contacts right here, you can just make them out here and here. They have to go into these two holes, here and here. So, and we have different voltages in the shop, right? So we may have swapped out a 120 volt coil for a 24 volt coil, and in doing so tried to jam those tabs in there and then broke this off, and then that was blocking it from making contact. So what I'm going to do is I'm going to slowly see if we can show you how to do this. So these two guys right here, these two pieces, are going to slowly go into these two holes on the bottom there, and if we just snap them in there, then we should be good to go. Beautiful. The only other thing I wanted to show you here was, here's all your ratings of the contactor. So the NEMAs are awesome in that all the information's on the front. IEC suck in that all the information is on the side here. So you have to get in and take the contactor off the DIN rail in order to see all your ratings for this bad boy. Or if you're smart, then you would look up that number right there, LC1D09, on the Google machine, and that'll give you all the information for this guy. Okay, so let's take a look now, and we'll take an ohmic reading on A1 and A2. Oh, that's nice, 6.9 ohms, right? So that one was 6.9. Let's put in the other forward contactor right beside. 6.6, beautiful. Okay, so now we got continuity. let's make sure that everything else works on this bad boy before we put it back in. So again, with authority 6.8 ohms, that's good. Okay, this is my normally closed. It should look like a short circuit. And it does, 0.3 ohms. This is my normally open. It should look like an open switch, which it is. And then I'm going to push the coil in. And there we got continuity. Okay, my fingers are in the way. But what I'm doing is I'm testing out these two leads right here. And I'm physically pushing the coil in. And there's my short. Beautiful. Okay, the other contacts, I got line 1 to T1. So we might as well check those guys out. See if somebody smoked those. There we go, 0.3 ohms, that's good. Okay, T1 to T2, that's open. This is when the contactor closes. 0.4, beautiful. And then finally this guy right here. And we'll shove this in, come on buddy. There we go, 0.5, beautiful. Okay, so all those contacts are working properly. Okay, the last thing I wanted to show you was this bad boy right here, the LAD 4RCG. I'm not entirely sure what this guy is, but based off of this symbol right here, I think it's a capacitor. Those are the two tabs that correspond to the coil. And remember that when the coil's magnetic field collapses, it can induce a voltage that can smoke other components, right? So I believe this is a capacitor so that when magnetic field collapses, it's just going to charge this guy up, and this is going to trap that current from going off and smoking something else. Nice. Okay, so let's put our meter to the side here. Okay, then we'll put everything back together now. So forward reverse contactor, we're going to slide them together. Gorgeous. Okay, on the back end here, we're going to keep those bad boys together. So we had this tab here, and let's see how simple this guy is to go in. I'm having a feeling this is going to be a pain in the... Maybe you're putting it on backwards there, donkey. So put this on there, and then, wow, that's nice and simple and easy. There we go. Okay, we'll have to go back on the video and make sure that I actually put that on the right way. Still feel like that's backwards, but alright, so there we go. Everything's nice and tight. Okay, and now we're going to put our jumpers on now. And we said that the ones that went line 1 to line 1, line 2 to line 2, and line 3 to line 3, they were on the top there. So let's see, this guy goes line 3 to line 3. Okay, so that's on the line side here. So we'll drop those bad boys in there. Back off all these terminals here. It was easier to get out than it is to get in. Yes, okay. Tighten those guys up. Beautiful. Okay, I got line 1, line 1, line 2, line 2, line 3, line 3. That's nice. Okay. And there's enough room to get some conductors in there. Okay. Then on the back end here, that's where the T1 and T3 are going to change state. So let's put those guys like this. Looks good. Just this one terminal needs to be backed off a touch. There we go. Okay, and the last thing we need to put in is our overload. So there's our overload there, and then these terminals right there, they just slide right in there. Beauty. And then don't forget to tighten those guys down, all three of them, otherwise your motor is going to be single phasing. Beautiful. Okay, so I had earlier said go buy a new contactor, but I think we just saved ourselves a bit of cash here. Okay, so we'll get the meter up and running here. My meter's batteries are low, so it's being a little bit temperamental. There we go. Okay, ohmic value. There we go. Okay, so A1 and A2, and we got a value of 6.8. Beautiful. Okay, I'll go on my other coil here for my forward. 6.8. Gorgeous. Alright, let's put everything back together and let's start in on our next video, the forward reverse starter control by the PLC. Alright guys, thanks for your patience. We'll see you in the next video.